Okay, so pause and write all these down. Make sure you have all these down. These are definitions that we've been introduced to, and now we're just going to review them and really make sure. If this is a graph, it doesn't look like I have directions down here. That's okay. We can figure it out. So if this is a graph of f, so write this down. This is the original function. Then we're going to sketch a possible graph of the derivative. Okay? So what we know is this slope from negative infinity to 1, 2, 3, 4, negative 4, is increasing, which means our derivative, so what happens if f is increasing, look up at your notes, if f is increasing, look at that second box there, what do we know? If f is increasing, then the derivative is, no, not increasing, because if the function is increasing, then the derivative is greater than 0, okay, which means the graph of the derivative will be greater than 0 from negative infinity to what number? Negative 4, okay? And then I'm going to start drawing, but I want to do one more thing. What's happening at negative 4? If I have a relative maximum and a horizontal tangent line, then that means the derivative will be changing from positive to negative. Okay, so watch, what did we say? If the original function is increasing from negative infinity to negative 4, and then at negative 4 it's 0, so the derivative has a point. Do you know what I'm thinking, you guys? Why don't we do all the zeros first? That might be an easier thing. So do you agree the derivative is 0 at negative 4? So we have a point there. And where else is the derivative 0? At 1. There's a minimum. So I'm going to put a point here at 1, 0. 1, 2, 3, 4, 5. At 5, we also have a 0 derivative. So at 5 here, it's 0. Okay. Here's something else we know. You ready? We also know that because this looks like the letter M, it's going down, that it is a negative x to what power? To the 4th power, because we have 1, 2, 3, 4. So if we know that, then we know the derivative. Well, what's the derivative of negative x to the 4? Negative 4x cubed, so we know that a negative cubic from pre-calculus is going to look like this. Okay, maybe with some other hills. Okay, let's go back. So we said 0, 0, 0, 0, 0, 0. Now this is increasing, which means the derivative will be positive. So this is a positive derivative. What's happening on f between negative 4 and 1? Negative 4 and 1. Do you agree that that's decreasing? So if this is decreasing, then the derivative is negative, okay? And so we need to keep this negative and go back up to the 1. Okay, what's happening between 1 and 5? It's increasing, so the derivative is going to be positive. If f is increasing, derivative is positive. Those are the definitions that you wrote down there. And it's going to come up, but it has to go back down because it has to hit this 0. And then what's happening from 5 to infinity? The function is decreasing, so the derivative is negative. And did that match our prediction that it should be a negative cubic? Yeah. Okay, let's turn the page. So graphical 1, pictured below is the graph of function f. Answer the following question about the derivative. Approximate the value of f prime of 4. Now again, this is a graph of the derivative. Sorry, this is a graph of the original function. So go to 1, 2, 3, 4, and put a point there. So to find f prime of 4, that's going to be the slope of the tangent line at x equals 4, and the word approximate, because we're going to try and draw the best tangent line, approximate the slope. So you do that now. Okay, so a tangent line, get your chopsticks out, and just do your best to draw the best tangent line you can. And let's see what I have here. I have up 3 over 1. Okay, that's what I got. I have seen up 5 over 2 before. Okay, so it's an approximation. It's okay if it's not perfect, but mine is up 3 over 1. All right, next question. At what value of x is the derivative equal to 0? So the derivative will equal 0 at a horizontal. You guys see how in calculus we have to annotate our questions, okay? So a horizontal tangent line, you can't go from the question to the answer in calculus. You have to go from the question to the definition, then to the answer, all right? So the definition of f prime of 0 is a horizontal tangent line, and that's also a relative max or min. So do you see how it says justify your answer? I justify the answer first. I write down the definition, and then we go and find the answers. So relative max or min is here, here, and here. So where are those heres? 1, 2, 3, 4. Is this the same graph as before? Oh. All right. Cool. So it's going to be x equals -4, x equals 1, and x equals 5. And justify your answer we already did. Okay. F prime of 0, f prime of x will equal 0 at a horizontal tangent line, which is a relative max or min, and those are the 3 x values. On what open intervals is the derivative less than 0? Ready for our justification? The derivative will be less than 0 when f of x is decreasing. Which occurs on, and they told us it's open, which is nice, so we're going to have open parentheses, and where is it decreasing? Well, it's got to be between the max and the min, so between -4 and 1, and then from 5 to positive infinity. If you've never seen that before, that means union. We're uniting both of these intervals to get the answer. Okay, hey, what is f prime of 0, f prime of x, excuse me, is greater than 0? Write your definition. These definitions are super important. F prime of 0 is greater, I've said that now 6 times. F prime of 0, it's really f prime of x is greater than 0. When f of x is increasing, which occurs, getting to the bottom of my video. So when is the function increasing? That's from -infinity to -4. And then between this min and the max, going from the min to the max, so that's x1 to x equals 5. All right, at what values of x does the graph of f prime go from being below the x-axis to above the x-axis? So that's if f prime is less than 0 to f prime is greater than 0. Okay, so where does the derivative, where does f, if f prime is less than 0, then that means f is decreasing. So where does f go from decreasing to increasing? Here we go. Increasing, decreasing, increasing, decreasing. So the derivative goes from negative to positive at 1. Maybe we need to draw a picture. At what values of x does the graph of f prime go from below the x-axis? That means the derivative is negative to the derivative being positive. Sorry, that's not clear. So this occurs at the relative minimum at x equals 1. So same question, but just now switched. Where does the graph of f prime go from being above the x-axis? So what you need to write is this. Above the x-axis means greater than 0. To below the x-axis means less than 0. So if the derivative switches from positive to negative, this occurs at relative maximums. X equals -4 and x equals 5. Okay, we're going to move on because what we just did is we analyzed the f graph to answer questions about the derivative, but now we're going to switch it up, you guys. We're going to switch it, and this is actually the derivative, and now we're going to answer questions about f, okay? And I'm actually going to save this for another video.